Guys, and welcome back to another episode of MicroProjects with Michelle. Today we're going to be nerding out with the data set about weather. I'm going to show you exactly what I do so you can follow along. Let's switch over to my computer and get started.
Okay, let's jump right in. If this is your first ever microproject, be sure to follow the guide linked in the description to set everything up. Similar to how we did the first microproject, we're going to want to run git fetch and git merge to put all of our files into the correct places. And then also for this microproject, if you've never used pandas or matplotlib before, make sure you run this command in the terminal just to make sure that pandas and matplotlib are installed. Even if you have used it before, I'd still recommend installing it just to make sure that you have the most updated version. Okay, and then once that's done, we're ready to begin. So here is the microproject with some background information. So the main thing we're going to be doing today is loading a CSV file into DataFrame and then doing some row selection and then nerd out a little bit with the NWS API. So that is going to be really exciting. We're going to end up making a scatter plot with hourly forecasts based on the location that we're in. So I'm very excited. Part one is to actually retrieve our forecast. So as we know, weather across the U.S. is different, based on where you are. And so the first step we're going to do is find the latitude and longitude based off of our location. And so what we're going to do is use Google Maps. So we can just do right-click or control right-click. And then as you can see, I'm currently on campus. But if you zoom in a little bit, you'll be able to find your own location based off where you are. And then you can also right-click on this little blue dot and then grab your coordinates. So this is your latitude and your longitude. So if you click on this, you can copy the coordinates, and we're going to copy this over into VS Code. I'm actually just going to put a comment down here so I can keep track of it. And then, so the first number is going to be the latitude and the second number is the longitude. So here they want us to store the latitude and longitude in two separate variables. So I'm going to just put the latitude as 40.11088, and then my longitude is going to be the negative one. Just going to replace this. And then I'm going to run this block of code just so that my variables update. Okay, so now we're good to move on to part 1.1, which is to find our forecast area endpoint. So as you can see, the API provides us the points endpoint using our latitude and longitude to find the weather forecast. And to get the URL for that, we're going to want to do api.weather.gov/points/latitude, longitude. Something that's really important in Python is to make sure that our strings are exactly the way that they're supposed to be. So make sure that you don't include any spaces or any extra slashes. So we are going to put this into strings and just copy over what they have right now. So https://api.weather.gov/points/ and now they want latitude, longitude. So we're going to replace latitude with our actual latitude, which we have up here, and then comma our longitude, which is right here. And then we're going to make sure that we don't put any extra spaces or anything. All right, so let's run it right here. And then they tell us to click the link to actually find our data. So here's the actual URL. It's the same one that we just typed up, but here it is just on the API. And you can do pretty print to kind of make it look better. Ooh, okay, let's keep it checked off. Okay, so looks good so far. So now we're going to actually retrieve the JSON data. So the format of the data that we see right here is something called JSON. And so this is kind of like a different version of ways that you can represent data. Some of you guys may know CSV from our first microproject. So this is the second way to store things using JSON. And so similarly to what we have for pd.read CSV, we can also do pd.read JSON. So here is the way that you do this. So you can see pd.read JSON, and then we're going to use points URL to read the data from this URL, and then we do 2 by p equals series. So I'm just going to copy this over, and this will give us how to store the JSON file into points JSON. So points URL, series. So then if we run this block of code, we'll be able to see what the points JSON is. So we have the ID, the type, geometry properties, dtype, etc., etc. Okay, so now that that's done, if we look back at here, the API, we can see that this JSON file contains a lot of information, right? However, what we want to get is the properties, because this will get all the properties about the location that we've requested. So if we look right here and we look under properties, this will give us the details, right? And so this is the specific part of the code, or sorry, of the JSON file that we want. And so to access this, it's actually very easy. All we have to do is print out points JSON and then properties. And so this will give us all the details about properties, which is right here, and it's actually the exact same. If you compare it to what we see in the API, it's the exact same right here. So that's good, that's what we wanted. Okay, and then for part 1.4, we want to record our forecast URL, right? And so from within here, we want to be able to get the URL. And so the way to do this is basically, we want to look up here, right, for the forecast URL. And then it's the forecast hourly URL specifically that we want, so not the forecast one. So it's going to be this one right here, and we can just copy and paste this over. Hourly forecast URL equals, and then put this into quotes. Oops, I'm going to delete this extra set of quotes I have right here. There. And that is our hourly forecast URL. Okay, and now here's like a checkpoint for tests. Let's just run these tests to make sure that we've done everything up until here correctly, and all tests pass, so that's good. Moving on to part 2, this is going to be loading our weather forecast as a data frame. So the first thing I want to do is to use pd.read JSON one more time. And so this time we're reading our hourly forecast URL. So we're going to do pd.read JSON. And then what we're going to want to do is put our new URL in, which is this one right here. Or we can actually use, since we've already made a variable called hourly forecast URL, we can just use this name. So that's the beauty of using variables. We don't have to keep typing the same URL over and over again. It's going to be typ equals, and it should be series. I believe that's what we had before, but let's double check to make sure it worked. Good. Okay. So now we've basically been able to read this in, and we've stored it into a Python variable. And now what we can do is, instead of the properties data, we're going to look for the periods data, and that's going to give us a set of data that contains the forecast for every hour of our location. So that's going to be the part with the actual data. So if we just do forecast JSON, we'll get this, right? And then within that, we'll be able to see the properties data in the JSON. So if we do forecast JSON with properties, then this will give all of this. And then finally, we want to get the periods data within the forecast JSON properties. And so that's going to give us the true data that we want to use. So now that we have this data, we're going to try to convert it into a data frame. And so here's the code to do that. They've already given it to us. It is df is equal to pd.dataframe and then forecast JSON properties periods. So this is very similar to what we have up here, forecast JSON properties periods. And so if we do this really quickly and run it, we'll be able to see our data. So as you can see, we have 156 rows total. And then it gives us the start time and the end time, as you can see right here. And then it also gives us the temperature, the units of Fahrenheit since we're in the US, wind speed, wind direction, a bunch of different datas for forecast. So that's very cool. And so let's just run the second set of test cases to make sure that we did this correctly. All tests pass, good. Okay, so moving on to part 3, or puzzle 3, which is exploring our weather. So what we've done so far is we have the hourly weather forecast for our location that we got from Google Maps with the latitude and longitude, and then we've been able to basically gather the actual live forecast, which is super cool. So now we're going to make a visualization based off of that. So df.warmest is the next variable that we're going to make, and we basically want to find the single row with the warmest temperature, right? And so if we remember, we're going to use a function called nlargest to do that. So we're going to do equals df.nlargest. And then we're going to pass in two things. The first thing is the int, so that's how many we want. Here we want the warmest, so that'd be like the first one, so 1. And then we also want the name of the column. So the column here is, if you look up here, the name of it is temperature. So copy paste it or just type it. And then if we give this a run, we'll be able to get the warmest temperature, which I'm in Champaign right now, and it's a whopping 44 degrees. So yeah, the weather here is not great, but yeah, 44 degrees Fahrenheit is going to be our largest temperature. Now we want the coldest temperature, so we're going to kind of do the same thing, but instead of n largest, we're going to use, I believe it's n smallest. Yes, n smallest. And again, we want the first, like the most small, so 1, and then temperature. And this will give us our coldest temperature, which is 22 degrees Fahrenheit. Okay. Alrighty, and so here are some test cases. We're going to run those. All tests passed. Good. Okay, moving on to puzzle 3.3, which is the forecast summary. So as you can see, short forecast column provides a brief summary of the forecasted condition of the sky for each hour. So the same conditions appear multiple times, so we want to get a count of how many times each value appears. And so we're going to use this new command called value counts. So df column.value counts is going to give us the command for the number of times the unique value appears in the column. So here we want the counts for the unique values of short forecast. So we're going to store this into a variable called forecast summary. So we're going to do df short forecast instead of column dot value counts, and then if we run this, we'll be able to get all of the unique values. So 35 mostly cloudy, 21 mostly sunny, 15 partly cloudy, etc., etc. Okay, let's run this set of tests to make sure that we did that correctly. All tests passed. Good. And so our last step is to create our visualization, which is obviously the most fun part. So we're going to create a scatter plot this time, which is going to be really exciting. So they give us the code here. So to create a very simple scatter plot that is just very basic, we're going to use df.plot.scatter and then x equals x column and y equals y column. So let's type that out. So we're going to do df.plot.scatter x equals. Here's where we're actually going to want to put the column names. So if you look right here, it says for the x-axis data, find and use the column name that contains the starting date/time for each hour. So we're going to look up here, what is our starting time? It's just going to be called start time. So like I said before, it's very important in Python to make sure that our names are exactly correct. So I'm just going to copy paste this in to make sure that I don't mess up with the formatting or anything. Looks like that. And then for y column, we want the column that contains the temperature for each hour. So temperature is going to be the column called, it's just called temperature. So we can just type that in. And if we run it, we should be able to see some sort of scatter plot. Ooh, okay, not bad, but definitely could be better. I'm noticing like a little bit of like something weird's going on with like the axes labels and axes markings. So the next part is to kind of like refine our scatter plot. So as you can see, they give us some instructions how to do this. Let's read them. So it's going to say, in the sub below, add the following parameters to the df.plot.scatter function to make sure each one is separated by commas. So we want the original x and y parameters. So we're just going to replace this. We want to keep the original parameters. Let's do this again. So we want to keep x as start time and y as temperature. Okay. They want us to do a title equals hourly temperature forecast for a location. So I'm going to do title equals hourly temperature forecast for Urbana, Illinois. Okay. And then we're going to do comma separated and do x ticks equals df.startTime.values : 6. That's basically going to give us only every 6th tick instead of every single one of them like they have right here. So it's going to make it look better. Okay, and then the next one they want us to do is add rot equals 90. So that's going to make the labels vertical instead of horizontal, so it's less cramped. And then grid equals true to get us some grid lines. And then fig size equals 10,6 to make it 10 inches by 6 inches. Okay, so let's just do this. And as you can see, we have this brand new visualization that looks much better, a lot easier to read, especially with these lines. And obviously this bar right here looks a lot better. We don't have all of this. And so I really encourage you guys to kind of mess around with this for a little bit, see if you can like change anything and kind of mess around with these variables. You can just like honestly, you can change things like the colors of the dots, you can change the size, and a bunch of different things. So I definitely recommend checking this out. But for now, let's run these tests to make sure that we did it correctly. All tests passed. Okay, so like I said before, we really encourage you guys to get creative with this project. There's a lot of different things that we can do. You don't even have to do your own location. You could do a different location as long as it's in the US. But if you do that, we really recommend you share it in the Discord channel because we would love to see all of your guys' visualizations. Alrighty, so now it's time for us to submit. So let's commit our lab to GitHub and then run the GitHub Actions grader. Let's make sure that we save our code. I'm just going to Control S, but you can also do File, Save All. And then we're going to go here. And then we're going to want to commit our work and then grade it. So let's run these commands. The first one is the git add command. I'm going to open my terminal. So terminal, new terminal. And I'll open this up for you guys so you can see it better. Git add -u, good. Git commit m with the message MicroProject completed. Okay, and then git push. Okay, so we've got it pushed, and now let's go over to the autograder. So we're gonna go to actions, workflow, find this one, and then do run workflow. Okay. There we go. And so now you can see it's grading, so we can click on this, and then we can click on this to actually see our thing run in real time. So this is really, really cool. I'm gonna come back though once this is done, and we can check our grade and see how we did. All right, so it looks like it's done auto grading. So if you go back to summary, we'll be able to see our score. So as we can see, we got 100%, all tests passed. So again, if any of these didn't pass for you, I'd recommend going into one of these parts to be able to kind of see, which part didn't work. But yeah, that concludes MicroProject number 2. Thank you guys so much for nerding out with me. And be sure to come back next week because I'll be doing MicroProject number 3, which is gonna be a really, really good one. Bye guys.